Hi everyone, thank you so much for taking part in this enrichment event. My name's Avril McLear and I work for the Advanced Maths Support Programme.
Hi, I'm Nicole Cousins and I also work for the Advanced Maths Support Programme.
We're really looking forward to spending some time with you exploring some maths. You are going to need something to write with and some paper. So if you don't have that with you now, perhaps just pause the video and go and get the things you'll need. Just a pen and paper's fine.
All right, so assuming that you now have something to write with, let's move on.
Okay, we'd like you to start by looking at the picture that you can see on screen now. What do you think that is? Any ideas? Nicole, what do you think it might be?
When I first saw this, I thought it looked like, do you remember those massive printers that used to spew out all those green and white stripy papers to plot matrix? It looks exactly. A little bit like that, or something from a very old science fiction movie.
Yeah, it does. It's actually a Animatron, and it's a really early example of like a computer game. It was introduced in New York as part of the World Fair in 1940. People were challenged to have a game against them and see if they could beat the computer. Any idea what percentage of people might have been able to beat that computer? What do you think, Nicole?
It's interesting, isn't it? So this picture here shows sort of more modern computer games, but that's like things like Mario Kart and stuff. Whereas I guess this computer is a more similar game to something like the computer trying to play chess or something, I guess, if it's an old version.
Yeah.
But, or I don't know, half, 50%.
50%, good guess, good guess. Actually, it was only around 10%. So why, I wonder, did only 10% of people manage to beat the computer? I wonder if it was because the computer was so well designed, or was it just that back then people hadn't sort of understood or developed strategies that would enable them to beat machines like this? We're going to explore a similar game today and see if we could find a way that we would have been able to beat the computer. Sound good, Nicole? Do you want to have a go at this game?
Yeah, excellent. Let's play. Okay,
brilliant. Right. I'd like you to start. All you need to do, please, is to choose a number between 1 and 4.
I'm going to go big. I'm going to go 4.
You're going to go 4. Okay.
Yep.
So I am then going to choose a number also between 1 and 4, and I'll add it to your number. Okay. And we're going to keep doing that until we get to the target of 23. And the person that gets to 23 is the winner. I don't have a really fancy graphic like you, Nicole, so I'm just going to do it on a bit of paper like this. Okay? So Nicole chose 4, I'm choosing 3, so we're now on 7. Your turn, Nicole.
All right, I'm going to keep going on. I'm going to keep going big, so I'm going to add another 4.
Okay, so 11. I'm going to go big as well. I'll go 4, please.
All right, I'm going to slow it down a little bit and add a 2.
2, okay. I'm going to add 1, please.
I'm going to keep going small and add 2.
2. I'll add 1.
Oh, I'm going to add 2.
Oh, that was a bit of an error on my part, wasn't it? I think I went a bit wrong there. Or maybe you got lucky. Well done, Nicole.
That's interesting, isn't it?
Yeah. Is it beginner's luck? Or did you really know what you were doing?
So, I wonder if it's because I went first. That was pretty handy.
Yeah, maybe. Should we play again?
Yeah, go on. Let's have another go.
Okay, fab.
Do you want to go first this time?
Yeah, good idea. Okay, I'm going to go. Can I start with 3, please?
Yep. I'm going to keep my going big strategy and 4. Add 4 to make 7.
Okay. I'll do the same. I'm going to add 4 as well, please.
All right. I'm going to add 3. So I'm 14.
Okay. I'm going to add 1 this time.
Okay. I'm going to add 2. to turn us up to 17.
Okay, I will add 2.
I think I only added 1. Add another one at 2. Perfect. So we're on 19, yeah?
Yeah.
Haha. So we're on 19. So I'm going to add 4. Yes!
I've done it again. Am I just really bad at this game, or are you really good, or is there a bit of a combination? I'm not sure, Nicole.
I don't know. I think we should just keep playing this game. I think it's great.
No, I'm bored now. Okay, it's over to you. We'd like you to play this game. So, just like we did, you can choose any number between 1 and 4. And then player 2 will also add a number between 1 and 4. We keep going until you get to exactly 23. You may be playing this against somebody, or you might be able to play against the computer.
There's a link on the PowerPoint that we're sharing, but there's also a link in the teacher's notes for the online game. So if you are going to be playing at home, then your teacher should have given you that information with the link. If not, it's this website at the bottom.
Okay, it's over to you now. We'd like you to play the same game that Nicole and I just did. So you're going to target of 23. Can you work on a strategy that enables you to always win? Have a think about your best first move. What move should you play when you start the game? If you get a strategy for that and you're happy that that would always enable you to win, have a think about how you would adapt the strategy for a different target number. So, and what about if you could add different numbers rather than just 1 to 4? Pause the video now and play that game.
Okay, welcome back everyone. If you haven't paused yet, really do pause now and play the game, but I'm assuming that you've all paused and played the game. So we're going to go on and we're going to have a look first of all at what that best first number was to start with. So when we ran this live, we had these results where 80% of students said that adding 3 was the best first move. So Avril and I are going to play out. Avril's going to go first and she's really hoping she's going to win this time.
Going to win this time.
Maybe. So she's going to go with that +3. And we're hoping that in your class, your results were fairly similar, where lots of you thought that adding 3 was the best first move, but we'll have a go. All right, so Avril, you're going to add 3 first, right?
I am. 3, please.
Okay, I'm going to slow it down to start off with and add 1.
Okay, I'll do the opposite. I'm going to add 4, please.
Okay, I'm going to add 2.
2, I'll add 3, please.
I'll add 2 again.
I'll go 3 again then, please.
Which puts me on 18. Avril, do you want another go?
Oh, nice try. No.
Are you sure?
I'm absolutely sure.
All right, fine. I'll race to the end and add 4.
Okay, I'll add 1 then, please. And I think I've won. Yay!
That's it. Avril is the winner. All right, so Avril, should we have a look at that game and try and work out why it is that you won?
Yeah, good idea. I kind of knew when I played that 3, I would win.
Yeah, it was a great first move, wasn't it? All right. So you went 3 and then I added 1.
Yeah. So then I added 4.
Okay. Then I added 2.
And I added 3.
And then I added 2 again.
So I added 3 again.
And this put me on the place where I really didn't want to be. So I just added 4.
And I added 1.
And got to the end. So let's have a look at those numbers that you were on. You might want to have a little chat for a few seconds, maybe pause the video and think about why were those numbers that Avril got were so good, meant that she definitely won. So we're going to have a look at those numbers. So when Avril ended on 18 and she passed 18 to me, it was my turn. No matter what I added, Avril could always finish. So if I added 1, she would add 4, and that ended on 23. If I added 2, she would add 3 and got to 23. And if I added 3 or 4, no matter what I added, Avril could always end up on 23. So if we went back one step to 13, no matter what I added, Avril could then make it to 18, which then meant that she could get to 23. So if we went back one step again, when she was put me on 8, no matter what I added, she could get to 13, then 18, and then 23. So 3 as that first move meant that no matter what I then went, she went to 8, then 13, then 18, and then 23. So what we want you to do now is have a think about those thoughts and apply it. Avril?
Okay, so we want you to generalize a bit of a strategy. So change the target number. We want you to start with a target number of 29, still just using 1, 2, 3, and 4. How does that affect perhaps the starting number and those key numbers that you're aiming to get to? Then try with a target number of 17 and then 28. When you've played those games and thought about how you would adapt your strategy, have a go at changing the target number and the choice of numbers that you can add each time. If you're really comfortable and confident with all of that, you can change it again. You can make up your own target numbers. You can choose the numbers that you're going to be able to add. Thinking again, remember that key first move was really important. Think how that changes with a different target number. And is there any time where it's actually better to go second rather than first? Pause the video, play these games, and think about how you would adapt your strategies for these games. Okay, hopefully you've had the chance to pause and play all those games. Hopefully you've found a winning strategy that works for any target number and with any choice of numbers. I'm sure you have realised that that first move really is vital.
So the game of Got It uses an area of mathematics called modular arithmetic. So modular arithmetic has also got a name called clock arithmetic. And it's based on a number system, whereas rather than counting up or adding up, you go round and round as if you're in a clock. So if we think about mod 5 or modulo 5, the numbers start 1, 2, 3, 4, 5. But then when we carry round, instead of saying 1, 2, 3, 4, 5, 6, 7, and 8, it would be 1, 2, 3, 4, 5, 1, 2, and 3 again. So we repeat the cycle.
So 8 mod 5 would be 3. So then can you work out what would 13 mod 5 be? And what about 18 mod 5? And 23 mod 5? How does that link to the game that we've been playing, the original game with the target of 23? Can you think about how you would link modular arithmetic to Got It?
So let's have a think. So we know that all of these 8, 13, 18, and 23, they were all 3 when we talked about modular 5. So as long as I'm always ending up on that 3 when we go around, then we know I'm going to win.
But what if we were adding different numbers? Or if we had different targets? So if our target was 24, that moves the finish line. It moves where we're aiming to get to on the clock. 24 in modulo 5 is 4. That's where the finish line was at, 4. What if we have a target of 25? What is 25 in modulo 5? It's 0, isn't it? So actually the finish line is at the top of the clock. What difference did that make in the game of Got It? Did you realise that in that occasion it was actually better to go second rather than first because you couldn't add 0. When we add a different range of numbers, we're changing the size of the clock. Okay, so if we're actually able to add up to 5, so 1, 2, 3, 4, or 5, we're working in modulo 6. If we're only adding up to 1, 2, 3, then we'd be working in modulo 4.
Modular arithmetic is really interesting. So it doesn't just have an application in Game of Got It, it has applications in all sorts of places. So one of those places is cryptography. So when you see a barcode or a QR code, then they use modular arithmetic as a way to code and decode your data. It's also got an application in music if you think that each octave is a cycle around the clock. It also has applications in one of my favorite areas of maths, it's a very obscure area of maths called topology. And in topology, you can take a mug and you can prove that a mug is exactly the same as a donut.
Brilliant.
It also discusses these weird and wonderful objects called Klein bottles. If you have a look at this for a moment, you might want to think about what a Klein bottle is. Where's the inside? Where's the outside? How would you fill it up? I'm not quite sure what foodstuff is the same as a Klein bottle. So the game of Got It is a type of game which has the overarching name of a game of NIM. The game of NIM is generally played with counters, so that's what we're going to look at now. And what happens in NIM is that you can take one or all or part of a pile of counters on your turn. And it's the person that removes the last counter, so there's nothing left, or the last counters, that wins. So if this was my board here, I could take a single red counter on my turn. I could take all of one pile, or I could take a single counter from a single pile. Avril, should we play?
Yes, please.
All right, so to start off with the game, we're going to start off with up to 6 piles of counters. I've just gone for 5 now, and then in each pile, I'm going to put either 1 or 2 counters in each pile. Okay, so let's go with 2 counters in the first 3 piles, and then I've got a single counter in the last 2 piles.
Okay.
All right, Avril, do you want to go first?
Yes, please. Can I have column 4, please?
So the single counter out from column 4. Excellent.
Yes, please.
All right, I'm going to take a single counter from column 3, leaving just 1 counter in that pile.
Okay, I'll take column 5, please, just that single one in 5.
Okay, great. I'm going to take a single counter from 2.
Okay. Can I please take the other counter from 2?
Yep. Okay, so that leaves 2 counters in column 1 and 1 counter in 3. I'm going to take a single counter from column 3. Oh.
I'm right, and I can take all of column 1.
Yeah, yes,
Yay,
you can.
I think I won.
Can we go back to playing Got It? I think I preferred Got It. I was much better at it. All right. So that game I set up and you went first. So this time, should we swap it round so that you set it up and I'll go first?
Yes, please.
Awesome. All right. So how many piles do you want, first of all? You can choose between 1 and 6.
Can I have 6, please?
Yep. I'll just add another column. All right. And where would you like 2 counters in?
Can I just have the first 2, please?
Yep.
And then the others as singles, please.
Absolutely. All right, so there is my whiteboard. Okay, and I'm going to go first. All right, so I'm going to take all of column 3, that single one there.
Okay, can I check, because I'm not sure if this is allowed. Can I take 1 from 1 and 1 from 2?
No, good check. Okay. No, you can only take all or part of 1 column.
1 column at a time, okay. Yep. That's a nice try. I'll take then all of column 1, please.
Brilliant. Okay, I'm going to take all of column 2.
All of 2. Okay. Can I take 5, please?
Oh, I'll take 4.
Yay! I'll take 6, please. I love this game.
All right, so we're now going to leave it over to you to play a game. For those of you that are playing online, the link links you to 4 different games. So Avril's going to detail through them. And the idea is that you choose to play each one as you go through. All right, Avril, do you want to explain the games?
Yeah. So you can play against the computer and the link, you have the link, or you can play against somebody like Nicole and I just did on pen and paper. Okay. So we want you to start with just single counters. So piles of single counters, please. You'll probably only play that a couple of times and then you'll be ready to move on. Okay. Then we want you to look at a mixture of piles with 1 or 2 counters in it. If you get a winning strategy for that one, you're going to move on to piles with 2 and 3 counters. Sorry, 1, 2 and 3 counters. Only move on to piles of any size if you feel really confident to do so. We're not really expecting many people to get onto that game. It's really important when you're playing this that you change up the starting board like Nicole and I did. So you might have 5 or you might have 6 different piles. Change it up a little bit. You need to think each time if you want to go first or second. And what is your first move? How are you going to start this game? When you're playing this, try and think about what a winning or losing board looks like. That'll help you to develop your strategy. So pause the video now, please, and have a go at this game.
All right, welcome back. We hope you've had some great times playing these games of NIM. If you haven't pressed pause and you haven't played the games, please, please, please do that now. But I'm going to assume you have, and we're going to move on. Okay. So what we'd like you to think about now is that it's your move and this is your board. We want you to think about what is the winning next move. Is it to take the single green counter? Is it to take both red counters? Or is it to remove one of the 2 black counters? We'd like you to discuss this with your partner, with your class, and see if you can come up with what you think the best move will be. We're going to pause so you can have a chat. Okay, so now you should have had a chat to the person sitting next to you or as a class and try to work out what you think the best move is. I'm going to show you some poll results from a previous session that we ran. And here you can see that removing the green counter was the preferred option. So I'm very quickly going to chat about why that might be the optimal strategy and how you might want to develop your thinking. So if we remove the green counter, you can see now that there's an even number of 2 piles and an even number of 1 piles. And when it's my opponent's turn, they can't take a counter away that leaves me with an even number. And the key is that 0 is an even number for this strategy. So what we want to think about is leaving that even. So if my opponent takes away a single red, I then just mirror that with a single black, leaving an even number of singles. So then my opponent takes away 1, I take away 1, my opponent takes away 1, and I take away 1. So leaving your opponent with an even number of everything is the key to winning at NIM.
Okay, we're just going to now have a bit of a chat through options you have after GCSE maths. So there are 3 options available to you. And although the maths a game theory that we were using today is only really in one of those options, problem solving, finding similar cases, testing strategies are all skills that you'll be using in any of these maths qualifications. I guess most of you have a good idea about A-level maths, so let's just talk about further maths and core maths. Further maths isn't just A-level maths but with harder examples. It looks at different areas of maths, including abstract ideas like complex numbers, which are really useful for engineering. Another area available within further maths is discrete or decision maths, which is often applied to business decisions, like how to deliver goods to customers in the most efficient way. Like in Amazon, they would consider those kind of problems. Or in the medical world, they need to match patients with organ donors. Core Maths is a reasonably new qualification. It isn't a whole A level, but it's designed to be studied alongside 3 other non-maths A levels or BTECs or T levels and diplomas. It's really useful as it helps with the maths that you'll meet in other subjects like chemistry, biology, psychology, social sciences, PE, geography, and many, many more. Many universities will give you a reduced offer if you complete core maths or further maths, even just AS further maths. It's really worth considering all this when you are making your choices. If you do want more information about any of these qualifications, just look at our website.
So the maths that we've been doing today is part of a whole area of maths called game theory. And game theory is a hugely influential area of maths that, in fact, there have been 12 Nobel Prizes awarded, including the 2020 Nobel Prize, which is amazing given that there is no Nobel Prize for mathematics. So the 2020 Nobel Prize for game theory was actually given to some economists. It can be used in all sorts of different ways, including economics. So there was a really famous example where in the 1970s, America banned tobacco advertising. So all the tobacco companies weren't allowed to advertise on TV anymore. And what actually happened was that all the tobacco companies, from not being able to advertise, their profits went up. So then they all employed lots of game theorists to say, what is going on? How can we maximize our profits while still trying to get our name out there? It's also used in biology. So building on from Darwin's theory of evolution, when we're looking at how species evolve and how they have sort of reached that peak efficiency, again, you would use game theory to have a look at how you know that the species is effectively done and going, yep, I'm now brilliant. It's used in farming. So farmers use game theory, which I just found fascinating, when they look at crops and how crops are rotated. And it's also used in political science. So the infamous November 2020 American election would have had a huge number of game theorists strategizing about it, trying to work out who should campaign where, what policies they should be talking about, what policies they should not be talking about. You can use game theory to help you make those decisions. It's also used in a 2001 film with Russell Crowe in it called A Beautiful Mind, where one of the very first mathematicians on game theory, called John Nash, used this wonderful bit of maths called the prisoner's dilemma. And what that does is it shows you basically when you should rat on your mates and when it's beneficial to keep their secret. We really hope you've enjoyed this session. If you've got any feedback, if you've got any thoughts, then you can email us at this address and put race to the target in the subject line so we know which session it is that you're engaged with. Also, if you enjoyed those the counter games or the games of NIM, there's an extra sort of bit of information about how you can use those on our Maths Club activities.
Thank you so much, everyone. Really, really hope you've enjoyed it.
Thanks.